So in chemical reactions, atoms often lose or gain electrons. Remember we talked about the metals tend to lose electrons, nonmetals tend to gain electrons. When an atom loses or gains electrons, then the number of electrons and the number of protons doesn't match up anymore, and so the atom will have a charge on it. A charged atom is called an ion. So ion is a charged atom. It becomes charged because of a change in the electrons. The number of protons doesn't change. And then we have special names for negative and positive ions. Positive ions are cations, negative ions or anions. And so you need to remember which is which. If you like cats, I have positive feelings for cats, except when they pee on the curtains, but generally I have positive feelings for cats. And so a cation is a positive ion, and that leaves the other one to be the anion. If that doesn't work for you because you hate cats, the word anion has one more N in it than cation does. Anion, negative, maybe that'll work for you. When we write the symbol for an ion, we use the element symbol for that element, and then we put the charge as a superscript in the right corner. And we usually write those charges with the magnitude first and then the sign. And that's a little different than what we do for math. So here's an example. Here's a lithium ion. It has a +1 charge. So in math, if you have x to the first power, you don't usually write the 1, do you? You would just write x. That's just x. And if you had x to the negative third power, you'd write the negative first. But when we do these ion symbols, we write the number first and then the charge. And the way I think of it is, this makes it look different than math. We're not going to get our symbol for phosphorus confused with a capital P that's a variable raised to the negative third power. So they're going to look different. So number first, then the sign. We always write the sign, but if it's a number 1, we don't write the number 1. I think chemists collectively have a thing against the number 1. We just don't write it. So here the lithium atom, it's lithium plus, not lithium 1 plus. And here this is a symbol for an electron. The charge on the electron is -1. So E with a minus sign. So the way these are formed is for atoms losing electrons to become ions. Here's a lithium atom. And then we have this reaction arrow, and here we see the formula for the lithium ion. It has a positive charge plus an electron. So the electron came away. Let's draw a picture. So if this is lithium, how many protons are in the nucleus? What's the number above lithium's symbol on the periodic table? 3. There's 3 protons in there. And how many electrons does lithium atom have? 3. It's the same number as the number of protons. So there's its 3 electrons out there. So we've got 3 electrons and 3 protons. 3 positives, 3 negatives adds up to 0, right? So if we get rid of one of these electrons, if we take one away, now we have 2 electrons, 2 negative charges, 3 positive charges. What does that add up to? +1, right? We have 3 and a -2, and that gives us 1. So the charge on the lithium ion is +1. And so here's the lithium ion, and what came off of it was 1 electron. The charge on the ion depends on how many electrons were gained or lost. For every electron that you lose, the charge becomes one more positive. Any questions? I think there's a homework problem that's kind of like this, and I don't know what happens. People try to make it too hard or something. It'll have things like this. And it'll want you to fill in the blank. So if I had a magnesium atom, and this is showing that 2 electrons are coming out of it, what's left when you take 2 electrons away from a magnesium atom? You're going to have 10 left. How does losing 2 electrons affect the charge on a magnesium? It becomes 2 positive, right? So this is going to be Mg 2 plus. So there's a homework problem that has some equations like this, and it's just asking you to fill in the blanks. Any questions? The nonmetals tend to gain electrons. If you get extra negative charges, then you're going to have a negative ion. And what do we call a negative ion? An anion. Nonmetals, negative. So the nonmetals make negative ions. In some ways, nonmetals and metals are kind of opposites. The metals make positive ions, the nonmetals make negative ions. They do that by gaining an electron. So if you've got fluorine and you give it an extra electron, now it's got a negative 1 charge. So the fluorine atom has 9 protons and 9 electrons. If we add an electron, now we've got 10 electrons. And we take a positive 9 and a negative 10, and that adds up to a negative 1. There's some math involved here, but it's not too hairy, is it? Whole numbers. Pretty small ones. The problem is those negative signs. They can be very pesky. So determine the charge of each ion. A nickel ion with 26 electrons. We need the periodic table for this. So we look at nickel on the periodic table to find how many protons does nickel have. 28. The number of protons doesn't change. So this has 28 protons. Sometimes we do those P plus. The protons are positive. And 26 electrons. So the difference between 28 and 26 is 2, right? And then the problem is, does the nickel ion have a positive charge or a negative charge? It has a positive charge. We have more positives than negatives. We're going to have a positive charge. A bromine ion. How many protons does bromine have? 35. Periodic table. The number of protons doesn't change. 35 protons, 36 electrons. We've got positive 35, negative 36. The difference between those two numbers is 1. And so the charge would be 1 minus a negative 1. So if we're going to write the symbol, which it doesn't specifically ask us to do, this would be Br with a minus, and this guy would be Ni 2 plus. Those would be the ion symbols. How about phosphorus? How many protons does phosphorus have? 15. And 18 electrons, it says. What's the charge? Negative 3. So if we were going to write the symbol, it would be 3 minus. Any questions? This stuff is just a lot of details. And we do need to be precise because this is how we communicate. We have to communicate, at least sometimes, by writing things down. And so scientists have agreed we're going to write things down in the same way. And so you just need to get with the program. And I know that bothers some students, but it is what it is. I think we've all accepted that in this country we need to drive on the right side of the road, right? Because if you don't, you're just going to have problems. So if you insist on writing your charges with the sign first and then the number, you're going to have some problems, especially with mastering chemistry, because mastering chemistry cares about things like that. Another example, find the number of protons and electrons in the S2 minus ion. How do we find the number of protons? Periodic table, right? We just look it up. Sulfur has 16 protons. The number of electrons, we're going to figure out based on the number of protons and the charge. If it has a negative charge, does that mean it has extra electrons or is it short electrons? Being short electrons seems to make sense because it's a negative charge when we think of subtracting things, right? But it having a negative charge means it has extra negative particles, extra electrons. So the number of electrons that it has, we have to add 2, and it's going to have 18 electrons. And this is one of those things that you just need to be able to back up and think about it rather than trying to memorize an equation. Just think about it. It's got this many protons. Overall, the charge is negative. That means it has extra electrons. How many extra? What's the charge? It's 2. It has 2 extra electrons. If the charge was a positive 3, that means that it's missing some electrons. How many? 3. Okay, so the magnitude of the charge tells us how many electrons it has either gained or lost. And the sign of the charge tells us whether it gained or lost them. There's a lot of information in the periodic table. One of the things that is helpful is the number of valence electrons. And we're not going to really explain what that is just yet, but we can predict by looking at the periodic table how many valence electrons the main group elements have. And there we're going to look at the numbers of the group. And there's actually 2 different ways of numbering the groups. There's the red ones, and it just goes straight across 1 through 18. That's what IUPAC uses in most of the world, I guess. And then there's the Roman numerals with the A's and the B's, and that's what we use in the US. The periodic table I give you for the exam has both of them. It says current US usage and IUPAC, and it identifies them. I think since we're currently in the US, we're going to use those, right? They also just give a lot more information. The number of valence electrons is equal to the group number. So if we look at group number 1, it has 1 valence. All those guys have 1 valence electron. If we jump over here to group number 4A, all of those elements have 4 valence electrons. Over here, group 8A, 8 valence electrons. It just flat out tells us. It's very convenient. Those main group elements tend to form ions in which they have the same number of valence electrons as the nearest noble gas. Which column is the noble gases? 8A. How many valence electrons do the noble gases have? 8. So these main group elements are going to form ions that have the same number of valence electrons as the noble gases. Are there any of the noble gases that don't have 8 valence electrons? How about helium? How many electrons does helium have? 2. So he's along with hydrogen in that baby brother status, and he violates the rules. But the rest of them have 8. Let's look at oxygen. Oxygen is in group 6A, right? That tells us it has how many valence electrons? 6. If oxygen forms an ion with a -2 charge, that means it gained 2 extra electrons, right? 6 valence electrons plus 2 is what? 8. Let's look at chlorine. How many valence electrons does a chlorine atom have? 7. The -1 charge tells us that the chlorine ion has 1 extra electron. 7 plus 1 is 8. Magnesium. How many valence electrons does a magnesium atom have? 2. It's in group 2A. If this has a +2 charge, that means it lost its 2 valence electrons. I think I'm not thrilled with how the book goes about this right here. Because they start talking about valence electrons and they're not actually telling you what they are, which I think is kind of a problem. So let's think about total number of electrons. So magnesium, the atom, has how many electrons total? 12. And the ion has a +2 charge, meaning that we lost 2 electrons, and so the ion has 10 electrons, right? Neon is in here. How many electrons does neon have? 10. Not only will these guys end up having the same number of valence electrons, they'll end up having the same number of total electrons as one of the noble gases. So the way I think about it, the noble gases are like those really cool kids back in high school. Do you remember high school? Some people loved high school, some people hated it. I wasn't real thrilled about high school. But there was that group of people, the in crowd, right? And there were a bunch of other people, not you guys, of course, but there were a bunch of other people that really wanted to be like the in crowd. And they would copy how they dressed. Did this happen in your high school? And they would try to do the same things. Come on, somebody's high school was like that. No? You guys are like a blank wall right now. This is no fun. Anyway, these are the cool elements, and all the elements are trying to be like them. You cannot change who you are, but you can change what you look like. The elements cannot change the number of protons, but they can change the number of electrons. And so they undergo chemical reactions in order to get the same number of electrons as the noble gases. Because it turns out that energetically, it's very stable. It's a good place to be. That whole thing works really great with most classes. I don't know. Based on the position in the periodic table, what ions do potassium and selenium tend to form? You know what? I need to go back here and point out a couple other things. The group 1A metals form +1 ions. The group 2A form 2+ ions. The group 3A form 3+ ions. Do you see a pattern there? Metals in the main group tend to form ions with the same charge as their group number. Those are the metals. The nonmetals, we need to be able to predict the charges just by looking at the periodic table. And all discussion of electrons aside, this is the non-scientific way of figuring it out. Group number equals charge for the cations, for the metals. Let's pretend we're playing a board game and you start your marker here and then you have to go back one space. All of these guys are -1. You start at the far right, you move back 1, those are -1, the next column's -2. I don't know why they don't put these guys in here. Nitrogen would be what? -3, and phosphorus is down here, -3. So it just goes, these guys don't form ions, 0, -1, -2, -3. Okay, so that being said, potassium. What kind of an ion, what charge is potassium going to form? Well, phosphorus forms -3. K is potassium. What group is potassium in? It's in group 1A. Oh, black on dark gray doesn't work so well. So the group 1A metals form +1. How about selenium? 2 negative. We find it in the periodic table. It's in group 6A. It has 6 valence electrons. It's going to want to gain 2 more to get 8. Or we can think of playing a board game, and we're going to start with krypton and go back -1 to bromine, -2 to selenium. Any questions? It's all hiding there in the periodic table. What about calcium? What charge is calcium going to have? 2+. It's a metal. Metals form positive ions. Non-metals, negative. Both start with N. It's going to form a 2+ because it's in group 2.